G'day. So today we're going to do something a little bit different, and I thought I'd do a demonstration of test-driven development. So it's a discipline I try to use as much as possible in developing my game, especially on the server side where the code is a little more easily testable. But for newcomers to the discipline, it's good to see it on a simpler example, so that the steps involved in test-driven development can come to the fore and be demonstrated and be emphasized instead of the actual functionality being developed. So, a quick introduction. Test-driven development is a way of writing code with high test coverage in very small iterations, which means that you get a lot of assurance that the behavior you want is correct, and if you ever change the code, you can run the tests again. You get a nice regression test suite that can help you to guarantee that the behavior you expect continues to exist. So the steps involved in TDD are: number 1, write a failing test; number 2, make that test pass; and number 3, refactor if you want. So writing a failing test, it should be the shortest possible failing test you can think of. The smaller the better, because small steps here mean that having small steps is what guarantees you high test coverage. Because if you write a small test and then a small bit of code that makes that test pass, then you can guarantee that that small piece of code is covered by a test, because if that small piece of code were not there, the test would fail. Another benefit of doing this in small steps is it makes it very easy to revert and change tack if it turns out that you're getting too bogged down in something and things are getting a bit more complicated than you expected. So write the test, and failure to commit to build counts as a test failure. The important thing is that you observe the test failing in the expected way. So if it fails for the wrong reason, that's no good. You have to fix that. And also, if it passes when you expect it to fail, that generally means that either the code already does the behavior that you didn't think it did yet, or the test is not doesn't exercise any new behavior where you think it did. So there's a little bit of confusion about the behavior, or the test is broken and needs to be fixed. So that's why it's important to observe it failing. If you don't observe it failing and you just assume that it works, then when you write the code and the test passes, if you haven't seen it fail, you can't be confident that the code actually is what made it pass. It's possible, and I've hit this before, that the test was broken and would always pass and wasn't actually exercising anything. So that's step 1. Step 2 is to make it pass. Just optimize for development speed. Whatever code you can write to make the test pass, and all other tests pass, just do it. This can include hard coding. This can include messy code, repetition, copy pasting. Ugly code is fine. The most important thing is just doing something quick to make it pass. Again, the reason here to make it to be quick is that if you try to write nice code here, you will end up writing more than is necessary to make the test pass, and therefore a lot of the code you write won't actually be covered by a test. So it's very tempting to write nice code and complete code and defensive code, but and part of the discipline is being disciplined enough to not write that code yet, not write new functionality until that functionality is required by a failing test. And then the third step is refactoring. So this is the point where you take this dirty code and make it nice. Often after a few iterations of this, you might get obvious repeated code that can be reduced into a more general algorithm. A lot of the time the refactoring is quite obvious, which is nice. So the exercise we'll be doing today is scoring a game of 10-pin bowling. We're using Python, and the approach we'll take is to create a game class which has two methods. One, roll, where you give it a number of pins for rolling a ball, and then at the end, score to get the score of the total score for the whole game. 10-pin bowling, pretty straightforward. There are 10 frames, each frame is 2 balls, and so each roll is up to 10 pins. Each pair of rolls is 10 or fewer pins, so that's a total of 20 rolls, possibly 21 under some circumstances. So in a frame, if you get all 10 pins down in 2 tries, so it takes you get some of them down in the rest of them in the next roll in the frame, then you get a bonus. So the very next roll in the first roll in the next frame, you get that bonus. Well, it's simpler than it sounds. We'll get to that behavior. And then a strike is if you get all 10 pins down on the first roll of a frame, and you get a bigger bonus then. And then if you get a spear or a strike in the very last frame, you get an extra ball. So in that case, you get 21 balls instead of 20. So let's get started. We start with an empty test file and an empty code file. And so the very first thing we want to do is to write a failing test. So as I mentioned, failure to compile or to run counts as a test failure. So we want to make a game class, so let's first do that. So just this is using PyTest, so a simple test case here, game equals game. So we'll run test, and we expect this to fail because this class doesn't exist. Yep, and that is failing for the right reason. By the way, the tool we're using here is called Cyber Dojo, cyber-dojo.org. It's a free tool. It's very useful for trying stuff out. It comes with a number of built-in exercises. It also allows collaboration from a number of users on the one exercise. So it's quite good, and it combines the code and the tests and running, and you get a nice list of history of how things are going. You can go through the history and revert back very easily. So it's a very useful tool. So we've got our test failing for the right reason. The simplest code we can write to make it pass is to define a class. And we'll just make it an empty class. We'll also have to import that into the test file. And it passes. Excellent. So that's that. Now we can move on to the next test. So we've got our game class. The next thing we should probably do is add, well, let's just go through the list. So we've got a function here that we need. Let's try adding that. So let's just generalize the name of this test here. Game.roll0. Again, it's the simplest code that exercises behavior we want, but that will fail. Here, another build error, no attribute role. So let's just add that. Again, this function doesn't have to do anything. All we're doing is calling a function, so all the function has to do is exist. Excellent. So we've got that function. And now the next test logically would be this other function here. If we should try to write the tests in terms of behavior. So these two functions are the outward behavior of this class. We can write tests that look at the internals of the class, but it's better to stick to the external API as much as possible, because that way, if the internal structure of the class changes, the tests don't break. They describe the behavior at a higher level, and so if you can keep that description at that high level, then the tests should never need to be rewritten when the code changes. So we want to test this score function. The reason why I want to go straight to the second function here is score it actually returns something, and so that's our only real way of testing the behavior. Roll pins is a one-way kind of, we give information to the class, and apart from being able to call that function, there's not really much feedback we can get from it. So score is the way we get feedback from the class, so it makes sense to do that one next. So a simple case here would be game.score. Now, the problem with this is that the test code should be code that exercises the class in a correct way. So it uses the class in the same way that the class ultimately will be used by a user, or whatever the audience is for the software we're writing. And if we look at the spec, it specifies that score is called once at the end of the game. Given that the game is going to be either 20 or 21 rolls, we should give it 20 or 21 rolls before asking for the score. The reason for doing that now, again, is if we eventually do enforce this and create some kind of error condition where if you call the score before the game is finished, then this test may break in the future. So the tests where possible should be realistic and correct usage of the class. So that's fairly straightforward. We can just go for I in 20. So we give it 20 rolls, and then we can check the score. So again, it's not it's the shortest test code that we will fail, but it also has to be test code that ultimately should work. When the software is finished, this test code should work. It should describe correct functionality. So that's why we need to call 20 here instead of going straight to just using the one. Now, this should fail because score doesn't exist. Yep, so it is failing for the correct reason. So then we can go to the code. And again, we don't need to return anything because there is no test that it returns anything. Okay, passed. So the next logical test would probably be to check the return value. So we can check the return value here, assert that equals 0. We can also probably rename this test. So it's now doing a little bit more than just testing that stuff exists. It's basically testing a 0 game, a game where every roll is a 0. And so the expected value here is that we don't have a return value here. Yep. And so the simplest way to make that test pass is just to return 0. Great. So now it's time to write another test, another failing test. This stage here in writing a failing test is generally the point in test-driven development where most of the design happens. So in writing a test, we have to consider what our desired behavior is. And one of the benefits of developing code this way is that in writing the test, you force yourself to think concretely about how the software works. So if we let's just go ones. So identical to the above, but we'll give it 20 rolls of 1 instead of 20 rolls of 0. Just because it's easy to write a test that way. And so what we expect the score to be there is 20. We roll, get one pin 20 times, the total score should be 20. Yep, and that is the expected failure. So now we have to look at the code and figure out how to distinguish between the two. So in one case, roll is called 20 times with 0, and we want the score to be 0. In the other case, roll is called 20 times with 1, and we want the score to be 20. So simplest way to make that pass would be maybe so let's go self dot pin was okay. This is the first time we have to figure out what the naming convention should be. Let's use camel case. So pin was so we've got a little flag here. Okay. And then if we roll if pins equals 1, that's true. And then if a pin was marked down, return 20, otherwise return 0. Well, we can maybe just that there. So it'll do it on every pin, but it'll still make the test pass, I think. Oh, self dot. Apologies, Python is not my primary language. Takes some getting used to. Okay, all the tests are passing. So now we can look at the test, the code rather. Obviously this code is terrible, but it makes the test pass. So to consider where we should go next, let's look at the code and figure out what functionality we want. Once we know what functionality we want, then we can write a failing test that describes that functionality. So it doesn't actually sum the rolls up. It just kind of assumes that you're either going to get 0 or 20 based on whether something was knocked down. So our next medium-term goal should probably be to actually calculate the sum of the pins. In this case, it's only really looking, ultimately this is being set by the last pin. So if there is a 1 pin rolled and then 19 zeros, we want the score to be 1. So let's try that one. And there is inconsistency here between naming, so I should probably fix that, but I'll do that in a refactoring step. Test 1. So here we get 1 roll of 1, and then 19 rolls of 0. and then we want to assert that score is 1. And this will fail because it will probably give us a 0 rather, using this case here. So let's run that test and double check, make sure we get the expected failure. Yep. So how do we distinguish that case? So I mean, ultimately the functionality of what we want here is to sum it up. Is there a quicker way to make all these tests pass than summing it up? Not that I can think of. So let's try it and see. If it takes too long to write this code, then that probably means it's a bigger step than we need, but we'll see how we go. Total 0. Plus pins. And then we just return software total. Not defined. The output is here. Equals 0. Okay. Again, this is my my Python knowledge showing. Give it a constructor, that might do it. Excellent. So now we've got our first real piece of functionality. We've got where every time we roll a number of pins, we're getting the total of those pins. So that's the base game here. That's basically this. I guess there's a limit of 10 here we could be looking at. So each frame there are only 10 pins to knock down, and so the first two balls together can't be more than 10. So let's write a test. Too many pins. So let's say we roll 20 rolls of something ridiculous, 50. So obviously each roll can't be 50 pins. So then what does this look like as a test failure? Again, this part here, writing this failing test, is where we design the behavior. And the question here is, how do we want this class to behave if we give it a bad number of pins? Simple answer might be a score of 0, maybe a score of -1 to indicate an error. So again, this is where we decide, because in writing this test, we describe our desired behavior, and so this is the phase of TDD where the design happens. Let's go -1. So if the score is -1, that indicates an error, because there's no other way that -1 can happen, because not in a normal game the score can only be 0 or higher. So score equals -1. So obviously this will fail. The expected score is probably 1,000. Yep. And so to make this pass, well, we want to make it pass as simply as possible. So literally, this is going to be hideous, but if self.total equals 1,000, then return -1. this may seem pathological and useless, but it does help. It is a useful step forward, and the reason is it's introduced this concept of an error case. It's a very specific error case we're checking for here, but we can generalize that in future, and returning an error. So we are creating this convention here. So everything's passing. We can do a refactor. So let's do that. I don't like the magic number of -1 here. So let's go. Let's define -1. Yeah, and then we can use that. So then we run test again, make sure everything still passes. Cool. And then we can also do the same to the test. So instead of checking -1 here, we can pull that. Oh, and that makes the test more readable because it's more clear now what's actually being tested instead of the -1 is. Yeah, I've got to think about what the -1 implies, but if you look at the test now, it's obvious that that's what we get. So again, we look at the code and figure out, okay, this is bad, but what would make it better? What do we want? We want this to be more generalized. We want we want an error case if a single roll is more than 10. So let's do that. Game dot roll 11, and then we give it 19 rolls of 0. And then we expect this to fail because 11 is too high, so we should get the same error. So we expect to get a failure here, and the failure we expect is because the score is going to be 11, which is fine according to the code, because the code only cares about 1,000. So we could copy paste this. If it's 11, then error. This is it makes it pass, but it's horrible. Can we generalize this? So we can't just say if it's more than 10 because this is the total score, and there's already a test where the total score is more than 10, and that's fine. So what is a way to improve this? So I add two directions here. I had to try to refactor or to describe the desired behavior more precisely with another test. So going from this to checking that, to doing a check here in roll is not an obvious or intuitive refactor. But is there another test case that would fail? The challenge here is in TDD discipline, whether a refactor here to move the check into roll would be too much of a jump. I think it's okay. We're not adding really new functionality. We've got last time we ran the tests, all the tests pass. So let's call this a refactor. We can put a well, we'd have to create an error state kind of that we will remember. So, for example, if we get the first roll as 11, then we need to remember that for the rest of the game that we're in an error state. So, yeah, we can do that. So, rolls. If pins is more than 10, then and so if total equals error, that's going to be our error state. And so if we're in error, then we're always going to be in error and nothing else should work. So if I were to just get rid of that now, one of those cases will pass, but the other will fail. So the 11 case will pass. It will correctly return the error because the rest are zeros. But the other 1000 case will fail, I think. 49. How did it get to 49? So 20 rolls of 50. So we're actually still calling this afterwards. So that should be in an else. Right. But we'll still get a failure here because now instead of 1000 we'll probably get 950-ish. No, it's passing. It's passing. Okay, well, there you go. It's passing because every roll is bad, and so none of the rolls count. So that's great. However, that's obviously not ideal because there is behavior here that is missing. Specifically, if we have one bad roll, but then a good roll, then it'll get screwed up. So if we get a roll of 11, or 50, or 100, then our total will be set to -1. And then if a subsequent roll is 1, for example, then the score would go up to 0 instead of staying at -1. So let's add a test for that. So we'll just describe I'll zoom out a bit. Describe the case here, which is error state persists well, that's really more of a description for this case, isn't it? So here it's persists even when subsequent rolls are good. So I'm combining all these into one test case called too many pins, but they could be split up into separate ones. I'm not really sure. As I have more test cases, maybe an obvious pattern of how to structure these will emerge. We're also getting a lot of repeated code here, so I'm not crazy about it. We should maybe think of a way to make these tests a little more nice. But let's do that from a green state. So we've got one roll of 11, and then let's say we want a roll of 1, and then 18 zeros. So in this case, the desired behavior is error because of this bad roll. The actual behavior is going to be 0 because after we get this -1, it's going to add 1 to it. So yep, we're getting a 0, but we want a -1. Cool. So to fix that, we need to add another check-in roll. So if we're already in an error state, then we want to just skip the roll, ignore any future input. So if total equals self.error, then return. And hopefully that'll do it. No. So this is the roll of 2050s. Int object is not callable. What have I done here? Error is not a function. There we go. Cool. All right, let's take a look at refactoring some of these tests because this is hideous. I guess we want to make sure we always give the game 20 pins, but that makes the tests a bit crufty with all this boilerplate. So we could create a test fixture, like a wrapper around the game class that can fill out the game with zeros. We could add a function to the game class that fills out the rest of the game with zeros. But that's kind of changing the API and is not ideal. I don't like changing the game code or the functional code just for the sake of testing. Like refactoring and making it more modular to make it more testable is fine, but adding functionality just to check things just for test is I find it a little iffy. It's less than ideal. We could also try to structure these tests with lists. But then we've still got to create the list and then loop through the list. So it doesn't really help much. Because the problem I have is all these for loops are kind of, they obscure the purpose of these tests. It's not obvious from this that the key point is that we get one roll of 1 and then the rest is zeros. We could add a function to just roll a number of zeros. That might help. Let's try that and see how it looks. It's not too bad. So we'll leave that one the way it is. This one will roll 19 zeros. It's not bad. It's still not ideal. It's not obvious why we're rolling zeros. And the reason why we're rolling zeros is to just... it implies the rest of this game doesn't matter. We only care about the scores before this. So that's fine. Let's just, this counts as a refactor. Let's just run our test again, make sure everything still passes. It doesn't. See, I was about to do more and then realized, well, refactoring should be done in small steps. See, I'm calling it without the game in all these cases. So, I mean, it saves us a couple of, a line of code, but it's not, it's still not ideal, but baby steps. It's an improvement. Right. So what I'd like is basically something like, I'm gonna finish, and then that just pads out the rest of the zeros. For the sake of testing, I'm just going to add that function to the class. We can always change it later, but the problem here is that it's not specified by the spec, this function, and so we could change the class to not have this function, and means that the class is now weighed down by this extra test code. But if it makes the test more readable, then that is a benefit. So let's just go with that. Finish game. Well, finish game implies, if I see finish game in some tests, it implies that it should be in all tests, which isn't good. And this actually also isn't trivial, because it means we're going to have to keep track of how many pins there have been. So that's not great. Again, we could do this with a test fixture. So let's just start sketching that out and see if it see how much work it is. If it gets too complicated again, we can just revert and do something else. But let's give it a shot. And a benefit of doing this in small iterations, everything we've done so far has been committed. Like all of these little circles up here are commits basically. And if I try for a bit and don't like the way this is going, I can just revert. That's a real benefit of working in small iterations. If I hadn't saved anything and I just started trying to write this text fixture and didn't like it, then undoing that might be a real pain. Because any programmer can tell you that you often get so bogged down with new code, and it just gets confusing, and you want to be able to just start again. And if you have committed recently, it's easy to revert. And also, if you're working in small iterations, it's psychologically easier to revert. You don't feel like you've thrown away too much. So we'll try this and see how it goes. But if we have to check it out, we can check it out. So class test game. So we'll give this a game object. We can write pass-through functions for the others just for readability. So roll game dot roll score return game dot score. So let's just do this first, and then zeros. Yeah, so we'll just refactor the current test to use this, and then we can, if that works, we can take the next step of adding a finish function. So that should just be a matter of calling test game, test game, test game, test game, test game, test game. That might be enough. Because the functions have the same names and the same behavior. I see. Init needs a self. Roll zeros. What's wrong here? Roll. Name game is not defined. Game. Self.game. I see. Self-taught game. Alright, now it'll work. Definitely. Nope. Test game has no attribute error. Ah, goodness. Well, actually, that's not too bad. The actual error code, well, no, the error code is part of the public API. It's behavior where, it's not in the spec, but it's where we define that behavior. So we'll, I don't like how much copying this is doing. I'll get it working, and then I'll try to change it to a subclass. I don't have much experience doing that in Python, but I can learn. But we'll get it working first. Self.error equals game.error. Nope, still yellow. Still not building. Game equals test game. Game not defined. Self.game.error. Every time it's self. Alright, that works. I'll add the functionality here, and then I'll make it a subclass. So I'll what we want to do is basically a function called fill with zeros or something similar, and game finish game with zeros. We can implement that later. Here we can count the number of roles, so num roles equals 0, and here we can add to that. So now we're counting the number of roles, and so here roles left equals 20 minus and then okay, so that should do that. We can get rid of this function, and then finish game with zeros. I need to solve here. So that it makes this test a little more clear what it's doing. We're rolling one and then that. So and this is not quite part of the test behavior. It's just a necessary boilerplate. So finish game with zeros. Finish game with zeros. Run the tests and see what happens. They all pass. All right. So are the tests better now? Maybe. It's subjective, I suppose. Is there value in turning this into a subclass? Maybe not. Let's leave it for now. We can always change it later. So let's look at the functionality we've got. So we've got a working error case if we've got a roll that's more than 10. Otherwise, we take all the rolls, add them up, and give that as the score. So maybe we can test that we actually do get 20 rolls. So test the number of rolls, game equals game dot roll and 0. So if we only give it one roll and try to get the score, then we get an error. So now that means that the game itself is going to have to start counting the number of rolls. Which, I mean, it would eventually have to do, so let's do that. Is there a simpler way to make this test pass? So we'd have to add a number here for the number of rolls. Every time we roll, we add 1 to that, and then at the time we get the score, we have to check the number of rolls. To make this pass, we just need more than 1 roll, so we could add a flag, set it to false, and then on our second roll we set it to true, which isn't really any easier. So let's just do it. Num rolls equals 0. Let's move it up here. Num rolls equals plus 1, and if self.num rolls is, well, equals 1 is for now functionally the same as more than or equal to 20. Let's just keep it simple. If it equals 1, then return. It's the simplest way conceptually to make this test pass. We want to return a value here. Warning. Cannot collect test class test game. I don't know what that means. Let's take a look. It's a PyTest thing, I'm guessing. Otherwise, what the hell does test class mean? Cannot collect test class. Okay, Google. PyTest was test prefix. Ignores classes that have a constructor. Okay. I think the problem is that it's just the name of the class. It doesn't like that it's called test game. So let's try to get rid of that warning. We can change the name to game fixture. This one I'm just using game because I can. I don't need any of the functionality from game fixture, and I think this is the same. Any one where we don't actually use the use this function is okay. So that one, this one. Pass. All right. I shouldn't have done all that together. I should have done one thing at a time. So that was both renaming some, changing some game fixtures to games, and also renaming test game to game fixture. Those should have been two separate commits in case something had gone wrong. But in any case, I want to undo one of them. But spilt milk. So looking at the code, this is too specific for us. So let's add another test. We can add another roll. Check that it's still error. That'll fail because now there are two rolls. Yep. And so less than 20 is, we'll do the job. It's the quickest way I can think of. I mean, 20 is arbitrary here. I mean, it's I could have done 2, or 3 or other, but now that's getting kind of pedantic. All right, so, well, not pedantic, but it's kind of arbitrary. Why 3 and not 20? It's just a number. There's no extra effort unless you count keystrokes. So yeah, that's a very reasonable behavior. We need 20 rolls. I guess similarly, if we have 25 rolls, we'd want it to, well, let's say 21 rolls of 0. We want it to fail. So let's do that. I'll just use a separate game object here, just because it makes the test a little more clear what it's doing. For I in range 21, game.roll 0. Set game.score equals game.error. So that's a failure because it thinks it's fine. We expect an error, but we're not getting an error. And so if we get 21 rolls, like for now, checking equals 21, equals 20 is enough. Ultimately, there will be a case when 21 rolls is required, but we can fix this as necessary. There's the simplest code that will pass. We might not get to that code for a while, possibly not during this stream. So, well, still got a failure. Why? Finish game with zeros. Okay, see. Not equal to, there we go. Alright, all passed. Now, so looking at the code, we've got that's great. I don't think we can really improve that for now. I will do some quick refactoring. I'm going to add a function, which I think is a reasonable function to add to this interface, which is instead of, I don't like that we have to keep checking score equals error. It's kind of ugly. So I want to add a function to check whether the game's in an error state. Well, that's a name. I don't like it. It's too long for our purposes. Something punchy would be nice. Is bad. Has failed. Is unrecoverable. This once it's in the state, it can't leave this state. So what's a good name? One of the hardest problems in programming is naming things. Look, we'll call it that for now. We can always change the name later. Return self.total equals self.error. So here we'll actually let's do it as a function on the game fixture. That's nicer, I think. So we can get rid of that. And then here we can use fixture. So game.is an error state. So that's a bit more readable. That will have to be changed to a game fixture. So the test fixture here is it lets us add test functionality that makes, well, the main reason I would do it is to make the tests more clear, more concise, remove repeated code, and it's a nice opportunity to give meaningful names to concepts that are relevant to the test. So this is a concept that makes sense in a test. It doesn't make any sense for the class itself, but it makes this test a lot more readable. So game equals a game. Finish the game with zeros, check the score. Make a game fixture, roll 0, check it's an error state. Roll 0, check it's still an error state. Actually, this is going to fail. Because it's not an error state. It's different. There's a difference between the game is in an unrecoverable error state, and if I get the score now, it's 0. I think. Well, the way that it checks this is by asking the score. So so it actually will pass, I think. Let's actually double check. I was expecting a failure, the different kind of failure, while the function was on the game class, because I wasn't just calling score, I was checking the stored score where it didn't have a check. But this is a different failure. Number of rolls is an error state. Game fixture, no attribute total. Okay, so that is yeah, so this is using internals of the game class that I don't want to be exposed. So so this actually using total there, if it were working, if I were to go self.game.score.total, it would build and then that test would fail. But if I go self.score game.score, then it should work. Everything should pass. Yeah, all right. So are these tests sufficiently clear? My personal preference when writing tests is to, at least on more real projects, is to use comments to describe the structure of the test using a given when then format. So, for example, given game when one roll is made, then so this kind of describes to a reader what the purpose of the test is. It demonstrates that the reason that the value of 0 here is not really relevant. It's just a roll, whereas up here, was a better example. Well, it's not as obvious now because it's concealed by the finished game with zeros, but sometimes the actual value is important. Here it's important because we're checking the actual score. Here it's important in that it's more than 10, but the actual value 50 doesn't matter. So if I would have got a comment here, I'd describe that I wouldn't describe this as 50, I'd describe this as greater than 10. And similarly here, because that's the property of the line of code that is relevant to the test. So that's kind of superfluous. When one roll is made, then the score is an error. Well, it can't be scored. I don't like calling this function here because that's a bad name, but whatever. We can fix it later. And when a second roll is made, then the game still can't be scored. So it makes the test a little more bulky. In real tests, it's a little more reasonable. In real projects, because the code is noise, so it's not always one line per comment. Additionally, if you're coming back to something a few months later, or you've got another person working on the project and they try to read your tests, it's a lot easier to comprehend the intent of the test by reading it here. A downside, of course, is that comments, in the words of, to paraphrase Robert Martin, a comment is a lie. It may not be a lie right now, but in the future it will be. Comments go out of date. Code doesn't go out of date. That's one of the great benefits of these tests, is that the test is working, active, executable documentation. And so if the behavior changes, this test as documentation has to change. So as long as the comments describe the functionality of the tests, it's probably okay. The function of these tests as documentation is contrasted more with comments in the code. So if I have a comment here about how the code works, it's better to not have those comments if possible, and instead describe that behavior with tests. That's not to say comments aren't sometimes necessary, but if they're just describing how the code works or how the function should be called or what the expected return value is, that kind of thing, it's much better to do that with tests. And if the tests are readable, then they make much better documentation as well. On Hellas, I often, if I'm trying to write XML for game data that I haven't, for a feature that I haven't used in a while, I'll check the tests to see how that works, because I know that the tests are accurate. If the tests are inaccurate, they will fail. So they are the best documentation. So it's nice. It makes the test longer, but that's okay. So I probably should have been doing that from the beginning, but I'll do it for this one, and I'll do it for future ones. I won't retroactively do the others, and I'll separate this out as a separate test case. Too few rolls, too many rolls. Game with more than 20 rolls. And it's worth specifying, and no expectation of a 21st roll. So say with 21 rolls, and well, there will be a future game roll where a 21st roll can happen, so it's worth specifying that. Again, it's relevant to the test design, and it's not obvious from the way the test is structured. And again, the actual number of rolls here, the value of the rolls doesn't really matter, so I don't have to specify what the value is. And in other tests I would say, yeah, it's relevant that this is more than 10. Here it's not really relevant what this is. Here the game can't be scored. Okay. I think it was just comments I did, but we'll double check that all the tests passed before moving on. Cool. Alright, so here's our code. What is next? Let's take a look at the spec. Each frame, the player has 2 opportunities to knock down 10 pins. So the 2 rolls within a frame need to be 10 or fewer. This reminds me, there are also cases where there can be fewer than 20 rolls validly. If you roll a strike, that is the first roll in a frame is 10 pins, then you don't get the second roll. So it's possible for the game to be 10 strikes, and then so 11 I think is the minimal number of rolls in a game. So it can be anywhere between 11 and 21. Because if you get 10 strikes, then you get an extra. The last frame, you get an extra roll. So let's first check that a frame is never more than 10 pins. A strike and then a frame of only 1 roll is going to be a bit complicated, but that's fine. One of the benefits here is if we do this in small iterations, we can. It's very natural for algorithms to emerge over time. So let's figure. So what behavior do we want, and how can we write a test for that? The behavior is that if we want to standardize the input such that if 2 rolls within a frame add up to more than 10, that's an error. So let's add a test. And already we can see the tests are 85 lines long and the code is 20, and that's not out of the ordinary that the test code is longer than the actual feature code. Test that the frame doesn't exceed 10. It's a wonderful test name, isn't it? Nice and verbose. I can't really think of an obvious better name, but we can always rename them later. So one of the other advantages of having these comments is we can sketch out the test before we write it. So given, and again, this lets us think about the functionality at a behavioral level instead of thinking about the test at a code level. And then once we have the functionality we written as comments, we can very easily write the code for it. But it's a slightly different mode of thinking, and so it's nice to be able to focus on behavior rather than code. So given the first role in a game is the three keywords here are given, when, and then. Given describes a state, like a setup, the state before the test stuff happens, when the thing that is being tested happens, and then the result. In this case, when is probably the only one we need. We don't need a given. So when the first two roles given the game, and the first two roles add up to more than 10, then the game is an error state. And so here, this is the first two roles add up to more than 10 is the behavior we want. So the code for this line is going to be a couple of calls to roll. But the value of those roles is relevant. The exact values is not relevant. What's relevant is that they add up to more than 10. So they will have actual numbers, but this comment here tells us what we should look for in those numbers, what those numbers mean. So let's do it. Game equals game fixture game dot roll. Let's say a 7. Game dot roll 7. And we'll also have to finish the game because otherwise we'll get an error state for this reason, and we want an error state for a different reason. So if we didn't have that, and we just added this check here, then this test would currently pass because the game is not finished yet, which means an error state. So that's why this is necessary. And it's also correct usage of the game class. So, well, I'll demonstrate that. So if we don't have that, this test passes, whereas we're in the red stage here. We're supposed to be writing a failing test. So what that means is that any code we write isn't going to be covered by a test, because this test always passes. Whether the functionality we intend to write here, whether it's there or not, this test will pass, which means that functionality does not have test coverage. So we need to observe the test failing. I almost forgot this. If I had forgotten it, then when I tried to run the test to prove that it failed, I would have been surprised and then realized, oh, here's a problem. So let's add this, and now it should pass, which means a test failure. There should not be an error state. The negatives get confusing, but right. So we want to be in an error state, but we're not. Whereas without this, we were in an error state for the wrong reason. So if we get two rolls of 7 and then zeros, we want to be in an error state. Which is the simplest way to cover that in a test. Let's go if self.num rolls equals 2 and self.total is more than 10. Self.total equals self.error. So if we're in, if there have been 2 rolls and we've got too many, then it'll fail. For this test case, it should work. Apologies. Wrong language. And so this will work, but it's very specific to this test case. Pass. To generalize the code, we should add another test. So what's the best way to do this? We could just copy paste this. Well, let's do that. We can always refactor later. 2 8s. No, actually, this is not good. See, that's not actually testing anything new. So we want first 2 rolls. Given a game with 2 rolls already made, the values of these rolls don't matter. It's just that they're valid rolls, so they are 0. But the comment tells us what's relevant about these lines of code and what isn't. When the next 2 rolls add up to more than 10, then the game is in error state. So this one should fail. Yep. For the right reason, good. Okay. So the problem here is we're only looking at the first 2, whereas we want to. So there's the first frame. We should be looking at every other frame. To make this pass, well, if I make this more than 2, is that going to be enough? I'm trying to remember what the other tests cover. Obviously, there is a test that does cover this, so that's not good enough. So that's fine. We'll have to make this a little more robust. So if we're currently in the second frame, which means that the number of rolls is 4. Let's just try that. 4. Since the first 2 rolls were 0s. Okay, that passes. It's terrible, but that's fine. We can look at why it's terrible and try to fix it. Fix it with more tests. So obviously a problem here is if the first 2 rolls have let's say we've got 4 rolls of 5, which is valid because the first frame is 10, the second frame is 10, but the total at the end of frame 4 is more than 10, so that is a case where this will hit, but it shouldn't. So let's do that. Now again, we can figure out a better way to structure these tests, but for now we'll just stick them all in here. This one doesn't really need too much explanation. 5, 5. No, actually it does. A game where the two valid frames totaling 110. So that's kind of describes what's relevant. I'm going to move these into their own test cases with meaningful names, but finishes. All right. Oh, so sorry. We want that to be not an error state. Excuse me for one moment. And I'm back. Sorry about that. Okay, so this is the expected error. I think. Yep, this one down here. So we want it to be fine, but it is an error state because we're here at the end of roll 4, and the total is more than 10. So again, let's add a quick flag. It's going to be ugly, but it'll describe what's going on. We can always generalize later. Self dot game was valid. Score frame 1 score. So if self wrong is 2. Frame 1 score equals f.total. If frame 1 score equals 10, then total equals 0. So here we can go frame. If that equals 4, then we're at the end of frame 2. So frame 2 score equals self.total minus if that is more than 10. There we go. Okay. Let's try that. Invalid syntax. Did I forget an if? If. Cool. Passed. The code's ugly, but we can kind of see what's going on. So we have to remember the frame 1 score in order to calculate the frame 2 score. Maybe that's not the best way to do this, but we ultimately do need to figure out what the score for this frame alone is, and that was the problem. So frame validity considers frames in frame validity doesn't look at total score, something like that. And can I break these ones up? Let's see. Well, let's do one thing at a time. Baby steps. We've broken out one test. It's just, there's no reason why it would fail, but it just can't hurt to double check these things. So these kind of work in the same test, but we can break it up into sections. Okay. Well, no, let's test that frame 1 doesn't exceed 10. And then frame 2. Okay. And test. So this still only really works for the first 2 frames, but if we then do the same for 3 frames, we'll get repeated code. It's similar to this, but more. And then once we see the pattern of the repetition, it should become very obvious what kind of refactoring we can do. So let's do that. So what is a test that would exercise this? So currently, we don't actually look at frame 3. So let's do frame 3. Frame 3 doesn't exceed 10. 4 rolls already made. Okay. So that one we expect to fail because it doesn't actually look for the validity of frame 3. Yep. Yep. Again, just verifying that it is failing for the right reason. So if self.rolls equals 6 and so this is similar to what we were doing before. And again, I've done it again. Failure. I didn't change this test, so why is it failing? Ah, okay. So we're getting here self.total is more than 10 because of this other case. So there's the case with the 4 5s is triggering this. So that's fine. But we're going to have to consider frame 1 score. If self-total 3 score equals self.total minus. No, that's not exactly accurate, but for the purpose of this test, it'll be fine. Because we're discounting, we're not considering the frame 2 score. Expected indented block. So that's fine. We can write a test that will exercise that. So that's passing. Good. So we'll do something similar to this. So frame 2 validity excludes doesn't count and then we'll write a similar one for that frame 3 validity doesn't count frame 2. 3 valid frames. We'll make the first one 0 frames where 2 and 3 total more than 10 points. So this will fail because it wants to not be an error state, but it is an error state. It's counting this and saying, okay, well, frame 3 is more than 10, therefore fail. Whereas the behavior we want is to only count these two. So we expect a failure here because the game is in an error state. Yes, okay. And so the solution is going to be very similar to this. So we'll have to remember frame 2 score. Minus self.frame 2 score minus, yeah. And that might do it. Pass. Okay, so now we can take a look at the code and see, can we generalize this with an algorithm? Let's see. So we can count the scores of previous frames. So instead of counting both of them separately, since we don't really need to count them separately, score of previous frames, and then if that equals 2, then we'll put that at the bottom here, because while we're looking at frame 1, previous frames shouldn't include frame 1. Equals self.total. So here we can go self.score total. Self.total. Here we'll set that to self.total again. If it's happening on an even number, ultimately this is gonna break if we start looking at strikes, but we can fix that later. So again, we only want to make the current test pass. We're not worrying about the features that haven't been written yet. We can certainly think about them and what the architectural consequences are, but it's not obvious to me, so I'm not going to worry too much about it. We can wait for that algorithm to emerge later. So, score previous frames, and then here we subtract score previous frames. That way we can use the same code for that and for that. So we can just call that this frame score, this frame score. And so now we can already see the nice repetition. So let's test that and see if it runs. We can delete these two variables here. Failure. Let's finish the refactor here. This frame score. This frame score. That should be self. Okay. Pass. Fantastic. So there's more we can do. This frame score. So we can try to mimic the other lines here, just to show the repetition. And then we'll move this into a loop. This frame score equals for our previous frames. This will be 0 initially, so this should still work. And then we can call that there. Test. Cool. I'm going to take a brief sidetrack here and make a new function to put into error state. It doesn't make the code any more terse, but it does better convey the intention here. So I think it's a little better. Pins are more than 10, put into error state. Yeah. If this frame score is more than 10, put into error state. It's more obvious to the reader, who's going to be me in the future, what this line's doing. So if we get this thing, then we're in error state. It's a little faster to comprehend than, okay, we're setting this total to this, and okay, what does that mean? Blah, blah, blah. All right, and test, make sure that still works. Fantastic. Now, let's go back to the code and see how we can generalize this. Well, let's go if mod 2 equals 0. This frame score equals that. If this frame score is 0, blah, blah. And then we can get rid of that. Doesn't work. What have I done? Mod. for programming stuff, it seems like Google is a superior search engine, unfortunately, but it is what it is. We want Python mod. It is. Okay, it's percentage. Beautiful. I finally try to deviate from my automatic C++ and I get it wrong. Percent. Pass. Okay, now I can give this a name. Is end of frame. Is that just so the intention of the I know what this means instead of just what the value is. Similar to describing code in comments, giving this a name tells me why I care about what this value is. It's not just a random if blah 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 math stuff. It's actually a meaningful concept. So if end of frame, calculate this frame score. This all makes perfect sense and nice and readable. If this frame score is more than 10, put it into our state. And then beautiful. That's nice and meaningful. Okay. Now, the case we considered here where this is not valid is when strikes happen. And strikes don't exist yet in the game. So we could go to strikes. The alternative is spares, which I think are, well, I'm not really sure which is more simple. Let's take a look at the spec. Let's see if there's anything I'm missing here. 10 frames, each frame 2 opportunities. So strikes, I think, are more complicated because the bonus has to look at the entire next frame instead of just the next pin. And also, it disrupts the frames because if you get a strike, then the frame is only one ball. So I think it might make sense to look at spares first. Yeah, let's look at spares. So a spare is when you knock down all 10 in both tries. You get, so within a frame, you get less than 10, and then you get the rest of them. So 6 and 4, 3 and 7, 5 and 5, 9 and 1, etc. If you get that, then you get a bonus. The very next roll, the first roll of the next frame, that gets added to your score. So, I think eventually we're going to have to just store all of the rolls in an array or something. But that doesn't mean that this is the next bit of code we're going to write. We shouldn't think about, well, when we write a failing test, we're designing behavior. We're specifying behavior we want, which is a little different from specifying code we want. But we can look at the code we have, figure out where the code is deficient, and use that to decide, well, what behavior do we want? So in looking at this, we can see the code is deficient because that's not always true. But to remedy that, we have to think about the behavior we want. Again, to make this work with strikes. Just a reminder, because it's going to happen quite a bit down the track, and possibly not in this stream, because this exercise is not trivial. But for now, we can look. It's not code that is prompting this; it's behavior. This is a new feature. So let's just get into it. So new test. Spares. So given a with which the first frame is a spare. When the next pin is 1, then the final score is 12. And then I can clarify 10 plus 1 plus bonus 1. So game equals game fixture. Can't type. Game dot roll. Let's give it 5s. Well, 6 and 4 might be more obvious. That what matters is some 5s and I don't know. It gets a bit. If they're identical and the humans pattern match and might see a pattern in there that isn't relevant, so that's more clear that that's what we've got there. 6 and 4, we've got a spare. Game dot roll 1. Nothing else is scored. Game dot finish game with 0s. Assert game dot score equals 12, and this should fail because it will be 11. Yes, so it is failing for the right reason. Excellent. Now, what is distinct about this that we can look at? How do we write quick code to make this pass? The relevant thing here is that it sums up to 10. So let's just look at that. Well, yeah, there are other tests here where we've got 21s, I think. Yep. So it we can't just look at whether the frame 2 has a value in it. All right, so let's just do that. So roll. So if it's under frame, so here we can do it if frame score is if this frame score equals 10, then self.score total should be +1. That should be enough for this test. Yep. So the obvious thing wrong with that is that the 1 is hard-coded, so let's fix that. I can repeat code, or I can try to use a loop maybe to make it a little parametric. Let's do that. Next pins equals 1, 2. First frame is lower. Next pin is N. And the final score is 10 plus N plus bare bonus of N. Next pin. Next pin. So we'll run through this with a value of 1, and then again with a value of 2. And so the case where it will fail is where this is 2, and it expects the final score to be 14, but it is instead 13, I think. Yes. All right. So now it gets complicated. We have to consider what the next pin is, but we don't have it yet. So we're trying to add a score here, but we don't know what that score is yet because it hasn't happened yet. So that means we are going to have to basically store everything in an array as it happens, and then do all the calculations at the end. I don't think there's a way around it now. At this point, this test requires us to start storing things. So you can see some of these small steps seem pathological and painful, but this seemingly straightforward test case is leading us to have to do a major architectural shift here. That was always inevitable, but now it's actually necessary, finally. Let's see. Is there a faster way to do this? Or do I just have to start storing things? Instead of storing everything, I can have a flag that says, just move that at the end because it's a little conceptually different. Self dot double should double next pin. That'll work. False. Yeah, okay, so we can talk to the future here with a flag. If it equals 10, then should double next pin equals true. And then here, ultimately we don't want the frame score to be, well, for the purpose of this check, we don't want the frame score to include the bonus, but maybe frame score is not what we should be counting for the purpose of for this test, this error check. But anyway, let's do it at the end here. It'll still work, so we can shift it as we need it. Ultimately, I think we're gonna have to have a separate frame score concept, including bonuses, that shouldn't be checked against 10. We should instead check the raw pins values, but that's a problem for the future. Let's see. So this is still every time we roll, and then if self dot should double next pin, then double next roll. That should be. Then self dot total equals self dot total plus pins. Yeah, we could do it up there. No, we can't. with this because the self the total is being counted here and checked against this. So if we do it up here, we'll start getting well, potentially future failures. This case I don't think will cause a failure, but it will cause problems if a spare leads to you going past 10. Actually, it would. If I check this here, then this first frame here would be 12 or 14. Sorry, 11. Or no, it'd be the next one doing it, wouldn't it? So it would be okay, but it doesn't really matter. It doesn't make it work. That's fine. It's the quickest code that'll work. Add the pins again, and then we want to set this to false. Oh, no. We don't need to, because the test will pass now. It's a glaring problem, but I don't think it's necessary. Maybe it is necessary. Let's see. 16. Why is it 116? Oh, it was 12. Why is it 16? Because all those subsequent zeros are turning into ones? Maybe? Well, that's obviously not enough, but well, let's try it. Should double next. See if that fixes it. Oh, everything's failing now. We're getting a bunch of error state problems. Let's comment that out. So here we're adding to the total, but the total is not just the total; it's also our error state. So and not self dot that's kind of ugly. All right, I've still got the 1612 problem here, which means that this line isn't fixing it. Oh, maybe it did. It was commented out. Let's see if that fixes it. What a mess. All right, so now we can maybe revert and think about this again. So that was a change in the test. Let's revert. Yep, revert. Run the test again. Should be the 1413 problem. Yep, alright. So now we can try again. That was just, we're getting too bogged down in just mess. Let's try again. So, the problem here is we're adding 1 here, and sometimes we don't know what this value is going to be yet. We don't know what the next roll is. So we want to send a message to the future saying add the number of pins. But it's the pins in the next roll. So oh, I know what the problem was. We're setting the flag here, and then directly after this, we're using the flag. That was the problem. Okay. Alright, let's revert back to this one and try to fix it. So we will call this up here. Yep. Might not need that. Error state. So this is giving us an error state. Why? Because so that is necessary then. So here we've got a spare, and then we add 1 here, and then that becomes 6. This becomes 11, and we're getting the failure. So we already have to create a distinction between the 2 pins in a frame and the total. Or we can have a little extra variable here for bonus points. Should add next roll as bonus. Then self dot bonus points, and therefore by doing that, the total isn't getting polluted by this, and these other checks can still work. So should add next roll as bonus. Let's try that. Failure. So 11 is failing now. We're getting 11, we want 12, because we're not actually adding the bonus. Self.total. Self.total equals self.total plus bonus points. Test. Red. 22. Okay, yeah. So we're getting an extra 10 points because this isn't here. We're not setting the flag back to false. All the subsequent zeros this is triggering. It's adding. Well, pins should be 0 in those cases, right? Roll 0 shouldn't matter because we're using pins here. Self.total. Self bonus points. That's a bug. It's green. Haha. Alright. So this line is something I want to add. It pains me that this isn't here. So let's figure out a test that makes this line necessary. So simple case would be let's go test spare bonus only counts 1 pin roll. One extra roll given game in which the first frame is a spare, when the next pin is a 1 and the pin after that is also a 1, then the third roll is doubled. The score is 10, 11, 12, 13. It'd be nice if I could convey this in code, but I'm not sure I can. So I've got a spare. I've got one. One. Search game dot score. We should add that with zeros. Game dot score equals 13, whereas it's going to give us 14. Invalid syntax. Really? Oh. So the expected failure is 14, I think. Yep. All right. And so now if I comment that out, that should be enough to fix it. No, it isn't. Interesting. Interesting. Because that's the wrong name. It's called add next roll's bonus. There we go. So that's a nice demonstration of, like, that was a line of code that seemed obvious, like we're going to need to add this line. It had, the code makes no sense without it. But that line was not necessary to make the previous test pass. It's an important line of code, but it's functionality that would have been there without test coverage. And so forcing myself to write a test, exercising it, a test that failed without that line, first of all, it demonstrated that the line actually is necessary and does something useful. Second, ensures that it's covered by a test, which means if that line is removed or breaks or something in future, then the test will fail. And it means that functionality is protected. Future refactors cannot break this functionality. If that line is so important, then it must be, it ought to be worth guaranteeing that behavior with a test. So if that behavior is so important, now I am confident that that behavior will not be broken. So now spares kind of work. Yeah. So this has been going for over 2 hours now. I am not going to be able to finish everything. Spares kind of work. Strikes would be next. Strikes are very disruptive because they break this functionality here, because that becomes not the definition of where a strike is. Strikes also have a cascading effect on scores, because whereas a spare gives you a bonus on the first pin of the frame, a strike gives you a bonus on the entire next frame. And if the next frame is a strike or a spare, then you get a cascading effect. And so calculating the bonus points is also more complicated. So I'm going to end this stream here. But if you are interested, you can. I encourage you to try this yourself. I'm not going to. Well, you can see the link here, so there's no harm in putting a link to this exercise. But if more than one person tries to change it, then it's going to get messy. So I would suggest that you probably try this from scratch yourself. It's a good practice. If you feel an itch to finish this thing, I would encourage you to try the whole thing from the top. This is actually quite a good exercise. It's better than I expected it to be. I hadn't prepared this in advance, and I didn't really know where I was going to go with this, but I think it's a really nice level of complexity once you start introducing spares and strikes. So Thank you very much for joining me, and have a great day.